Good morning everyone. My name is CH Srinath. I am from CSC department. Today's subject is design and analysis of algorithms, and today's topic about recompute the MST. Recompute the MST. Introduction about MST. The minimum spanning tree connects all nodes in a graph with the minimum total edge weight, and recomputing the MST is necessary when the graph changes due to edge or node updates. And understanding how to efficiently update the MST is critical for dynamic network applications. The introduction about minimum spanning tree is connects the all nodes in a graph with the minimum total edge weight, and recomputing the MST is necessary when the graph changes due to edge or node updates. And understanding how to efficiently update the MST is critical for dynamic network applications. And this is the introduction about MST. And next slide is the when to recompute the MST. Recompute the MST after adding or removing edges, and that could affect the overall minimum spanning structure. Changes in edge weights that alter the current MST also requires recomputation. That not all modifications necessitate a full recomputation. Some can be handled with incremental updates, and this is the picture of the recompute the MST. What is that? A scenario 1 and scenario 1, copy 1, scenario 2, and this is the building 1, wall 2, wall 3. This is the recompute the MST after adding or removing the edges, and the changes in edge weights that alter the current MST also requires a recomputation. Not all modifications necessitate a full recomputation. Some can be handled with incremental updates. This is the recompute of the MST. And next slide is the types of graph changes. Edge addition, removal, or weight modification are common types of graph updates. The types of graph changes are edge addition and removal or weight modification, and are common types of graph updates. The node insertions or deletions can also impact the MST structure. The recognizing the type of change helps determine the most efficient recomputation strategy. The edge addition, removal, or weight modification are common types of graph updates. And next one is node insertion or deletions can also impact the MST structure. These are the types of graph changes. And next slide is the algorithms for recomputing MST. Classic algorithms like Kruskal and Prim's are foundational for MST computation. These algorithms can be adapted for incremental or decremental updates to avoid full recomputation, and efficient algorithms focus on local modifications rather than reprocessing the entire graph. The algorithms for recomputing MST is the classic algorithms like Kruskal and Prim's foundational of for MST computation, and these algorithms can be adapted for incremental or decremental updates to avoid full recomputation. And efficient algorithms focus on local modifications rather than reprocessing in the entire graph. These are the picture of the Prim's algorithm for growing MST. And next, this is about algorithms for recomputing MST. And next slide is the incremental MST algorithms. Incremental algorithms updates the MST when new edges are added with minimal recalculations. They work by checking if the new edge creates a cycle and replacing edges if it leads to a lower total weight. And these methods significantly improve efficiency in dynamic graphs where additions are frequent. The incremental algorithms update the MST minimum spanning tree, and when new edges are added with minimal recalculations, and they work by checking if the new edge creates a cycle and replacing edges if it is leads to a lower total weight. And these methods significantly improve efficiency in dynamic graphs where additions are frequent. These are the incremental MST algorithms, and this is a picture about graph algorithms. Water graphs is a graph is an abstract data structure to implement mathematical concepts of graphs. And graph is a collection of vertices, also called as nodes, and edges that connect the vertices. And this graph is often viewed as a generalized of tree structure. Definition is a graph is defined G is defined as an ordered set of graph algorithms. These are the incremental MST algorithms. And next slide is the decremental MST algorithms. Decremental algorithms handle edge removals and update the MST accordingly, and they identify if the removed edge was part of the MST and then find alternative paths if necessary. These algorithms enable efficient updates without recomputing from scratch, and this decremental algorithm handles edge removals and updates the MST accordingly, and these algorithms enable efficient updates without recomputing from scratch, and they identify if the removed edge was a part of the MST and then find alternative paths if necessary. This is the decremental MST algorithms. And next slide is the handling edge weight changes. When weights change, it's important to determine if the edge was part of the MST, and increasing an edge weight may break the MST if the edge was critical. Decreasing an edge weight can lead to a new, more optimal MST for reassessment. This when weights changes, it's important to determine if the edge was part of the MST, and increasing an edge weight may break the MST if that edge was critical, and decreasing an edge weight can lead to a new, more optimal MST after reassessment. This is this is a picture about determine the total edge weight and minimum spanning tree connecting the cities. See this picture like city A, city B, city C, city D, city E, and city F. These are rows and columns named with a city A, city B, city C, and city D, city E, city F. These these are the entered exact numbers, and this is about the handling edge weight changes. And next slide is the data structures for efficient recompute. Union find structures help efficiently manage connectivity during updates, and priority queues assist is selecting edges during incremental or decremental steps. The advanced data structures like dynamic trees support fast updates in large graphs. This is the union find structures helps efficiently manage connectivity during updates, and this is priority queues assist in selecting edges during incremental and decremental steps. These advanced data structures like dynamic trees support fast updates in large graphs. This is the minimum spanning tree, and deliverable spanning subgraph frames algorithm, Driscoll algorithm. This is about data structure for efficient recompute. And next one is practical applications of recompute MST. Network design and optimization often require dynamic MST updates. Real-time systems like transportation station or communication network depend on quick adjustments. Recomputing the MST ensures minimal cost and optimal connectivity in changing environments. And conclusion and future directions. Recomputing the MST efficiently is essential for dynamic graph management, and ongoing research focuses on developing faster algorithms and better data structures. Mastering these techniques enhances performance in very real world applications. These are the conclusion and future directions about a minimum spamming tree. And thank you. Thank you, sir and madam.